Hi everyone. So when I was grading your worksheet on population dynamics part 2, I saw some common missed questions. So I wanted to take a moment to go over those with you and make sure that we are all settled on how to determine these answers. So for the first question, I asked you to predict how many humans will be added to the global population each year. Maybe predict wasn't the best word to put here because you would calculate this out to make your prediction, but it's just based off of the average, or the approximate average is 150,000 humans die each day globally, and 350,000 humans are born each day. So what I would do to find out what my net growth is each day is I would subtract 350,000 minus 150,000, and that would give me 200,000. And then I would multiply that by 365 to get what this would be for the year. And that would give me 73 million. So I would increase population by 73 million people globally each year. Okay, second question is to predict the current global human population is around 7.8 billion people. What will the population average be 5 years from now? In general, what will happen? So in general, you can say that the population is going to increase, right? Because we see that we're increasing by 73 million each day. That's going to be, we'll say, in the green because we are increasing. And then for our answer here, we would say, in general, population will increase. And if we wanted to be more specific about what amount population would increase, then I would take that 73 million from my previous answer and I would multiply that by 5 to get 365 million. So that's how many people we're increasing the planet by in 5 years. And then I would add that to the current population, which is 7.8 billion. Dealing with some pretty large numbers here. A lot of zeros. And that would give me, let's see, my calculator here is giving me scientific notation, but we know that it would be close to 8 billion. So that's what value is showing here. Okay, animal leaves a population that's known as immigration, or I'm sorry, leaves a population that's known as emigration with an E. And if we join a population, that's known as immigration. Oops. I always get which one has one E or two, or one M or two M's mixed up. All right, and then the last couple questions where we got a little bit stuck were with this lemming and predator owls population. So it's helpful to know a little bit of background information about the lemmings and the owls. Basically, the lemmings are prey for the owls, and the lemming population, they're not very good at controlling themselves as far as reaching their carrying capacity goes. They shoot right up and reach their carrying capacity and then drop off really quickly because they eat all of the moss that's in the area until there's no moss left. And because they're a small rodent, they're able to reproduce really rapidly, so they have these peaks and crashes. And what happens with the owl population is that soon after the lemming population peaks, the owl population is also going to peak. And so then once the lemming population starts to decline, so does the owl population. And it's not until the lemming population starts to pick up again, that the owl population also starts to then pick up. So owls aren't going to be reproducing if they don't have a food source. And if the lemming is their food source, then they're not going to be reproducing if there's not enough lemmings. So the first question is asking based off of the graph, and granted we don't have grid lines here, but based off the graph, how many years are between each lemming population crash? So if I take a look at the crashes, which are my valleys, that looks to be around 2.5. This looks to be around maybe 6.5. And so I could say that my lemming population crash would then be about every 4 years. All right, what is the relationship between the owl population and the lemming population? Well, we know that it's a predator-prey relationship because the owls' numbers are dependent on the lemmings' numbers. So we see that when lemming falls, owl population also falls. So we can say that they are related by a predator-prey relationship. Describe how the peak in owl population compares to the peak in lemming population. Okay, so we have our peak owl population just before or right around the peak lemming population as well. So once owl population peaks, lemming population is also peaking, and then we're both are dropping relatively soon. So we can say that owl population peaks just before lemming population, which makes sense because the lemmings are going to die off sharply once they run out of food. Okay, this graph does not show population, but rather population density. So this graph is not necessarily showing us the number of individuals, but the density of the organisms. So density would show that we're indicating an area. So this would be the number of organisms in a certain area. All right, hopefully this helped clear up some misconceptions with this activity, and I will also post a link on lemmings and owls if you would like to read a little bit more about them. Thanks.